Hi guys, welcome to the first recitation for EE3413 or Analysis and Design of Control System. On this week, I will be solving some problems on differential equations. For those who already know how to solve this, then it's good for you. But for some of you who don't really understand or forgot how to solve this kind of problems, then you can follow this recitation. Here I have four problems, and let's solve the first one. Okay, the first problem, let's rewrite the first problem. It's dx over dt plus 2x plus 1 with initial condition x0 equals 5. Okay, to solve this, define a function gamma. So gamma is a function defined as e to the integral of 2 dt. So this is equivalent to e to the power of 2t. Since and this is always greater than 0, right? So we can multiply the original problem with gamma. So let's rewrite dx over dt plus 2x equals 1. Multiply both sides with gamma, so we have e 2t dx over dt plus 2 e 2t x equals to e 2t. Okay, but we know that this term here is d e 2tx over dt, right? So we have d e 2tx over dt equals to e 2t, and then we integrate both sides, so we have integral of d e 2tx equals to integral of e 2t dt, and then we solve the integral. This is equals to itself, so e 2tx plus some constant, say c1. This one is 2e 2t plus c2. Okay, and this is equivalent to e 2t equals to 2e 2t plus c2 minus c1, but we do not know c1 and c2, also we can say c2 minus c1 equals to c, so let's say just c. And then sorry, we have x right here, and then we can multiply both sides with e to the power minus 2t, so that we have x equals to, sorry, so this will be 1/2, right? This will be 1/2. Oops. Okay, this is 1/2. So we multiply both sides with e to the power of minus 2t. We have 1/2 plus we have c e to the power minus 2t. So this is the general equation, right? So how do we know that this is the general solution? So we just simply compute this. So dx over dt is what? So dx over dt is minus 2c e minus 2t plus 2x, right? So this is x, so 1 plus 2c e minus 2t equals 1. So this confirms that x is the general solution of this differential equation, but we haven't really solved because we need to find c such that it satisfies the initial condition, right? So we know that this confirms that x 1 half plus c e minus 2t is a solution to dx to x equals 1. Okay, so to find c, we use the initial condition x0 equal to 5. So we know x equal to 5 when t equals 0, right? So 1 half plus c e minus 2 times 0 is 0, e to the 0 is 1. So we have 5 equals 1 half plus c, or c is 5 minus 1 half, 4.5. Thus the solution is x equals to 1 half plus 4.5 e to the minus 2 t. Okay, so this is the solution for the first problem. Okay, now let's move on to the second problem. So let's rewrite the second problem. So the second problem is t dx over dt plus 2x equals to t square minus t plus 1 with initial condition x1 equals to 1 half. Okay, so we can use similar steps as we did on the first problem. So let's transform this problem into a similar form as the first problem. So on the first problem we do not have anything right here, right, on the term of dx over dt. So let's move this t to the other side. So this problem, but we need to assume that assuming that t is not 0, we have dx over dt 2 over tx equals to, so you divide this with t minus 1 plus 1 over t, right? Okay, so this problem has the same structure as the first problem, right? So we can follow similar step. So we need to define a new function like this, gamma. So let's define the function. Define gamma as the integral on this term here, right? So e to the power of integral to this term, so let's say it's tau d tau. Okay, so this equivalent to e, so integral of 2 over tau is nothing but 2 log t, right? So this is a natural logarithm, but we know that this is nothing but e to the log absolute value of t square, right? But absolute value of t square is nothing but t square. They are equal, so this turns into e to the log t square. But e to the log is just t square, right? So we can multiply both sides of this problem with gamma. Let's do that. So we have t square dx over dt plus t square times 2 over t. We have 2t x multiplied by t square. So t cube minus t square plus t. So this holds still, assuming that t is not 0, because if t is 0 then the whole equation is 0, so it's meaningless. So we see that this assumption somehow makes sense. Now realize that this term right here is nothing but d t square x over dt, right? So if you apply chain rule, then dt square x over dt equals to these terms right here. Okay, so we have dt square x over dt equals to t cube minus t square plus t. Okay, so let's do the same step. So we integrate both sides. So we integrate this d square x, integrate t cube minus t square plus t dt. And this, what are these? So this is nothing but the term right here, t square x plus the constant c1, and this one right here, t cube is 1/4 to the 4 minus 1/3 to the third, right? And then this one is 1/2 t square plus the second constant c2. Since we assume that t is not 0, then we can multiply both sides with 1 over t square. So we have x equals to 1/4 t square minus 1/3 t plus 1/2 plus c over t square, where c is c2 minus c1 like before. Okay, so this is the general solution. To check, you can substitute x to this term and compute dx over dt and substitute into this term, and you can see that this holds. Okay, so that's how you check that this is the general solution of the problem. Now we need to find c given this initial condition, right? So the initial condition says that x1 equals 1/2. So when t equal to 1, x is 1/2, right? Then from x1 equals 1/2, we get 1/2. So t equals 1, 1/4 minus 1/3 plus 1/2 plus c, t equals to 1. Okay, so cancels, this gives you C is 1/3 minus 1/4 is 1/12. Okay, thus the solution is x equals 1/4 t square minus 1/3 t plus 1/2 plus 1/12 times t square. So this is the final solution of the initial value problem for number 2. Alright, so let's move on to the third problem. So in problem number 3 we have z dot or dz over dt equals to 1/t z square. Okay, so d z over dt equals to 1/t z square with initial condition z1 equals to, okay, so here we can exchange, right? So given z is not 0, then we can have dz over dt equals to 1/t z squared. So this is equivalent to z to the power of minus 2 dz t minus 1 dt, right? So this also assumes that t is not 0, because if t is 0 then this problem is undefined. With t is not 0. Okay, now we can integrate both sides. So z minus 2 dz, right? So this you get minus 1/z plus c1. This one is log of t plus c2. Again we have minus 1/z equals to log absolute value of t plus c. So we have 1/z is c minus log absolute value of t. So z is 1/this. Okay, and the initial condition says z1 equals 2. So from z1 equals 2 we get 2 equals 1/c minus log 1, right? Log 1. But since we know that e to the 0 is 1, then then we know that log 1 is 0. Thus c is um, 1/2. Therefore the solution is z equals to 1 over 1/2 minus log absolute value of t. Okay, so that is the final solution of problem number 3. Okay, the last problem, number 4, y dot equals ty cube over 1 square root of 1 plus t square. All right, let's rewrite the problem. So we have dy over dt equals ty cube over square root 1 plus t square with initial condition y0 equals -1. Okay, now again we assume that y is not 0, then dy over dt equals ty cube. Then this is nothing but y to the power minus 3, right? Dy equals t over square root 1 plus t squared dt. And we can integrate both sides. Integration y 3 dy, integration of t over square root plus t squared dt. Okay, so this we know that, so this, sorry, integrate y to the power minus 3 dy is 1 over y cube dy. It's equivalent to minus 1/2 y power minus 2 plus c, and this one here one plus t squared dt. But we know that so if you compute the derivative of 1 plus t squared using chain rule, we know that this derivative equals to 1/2 1 plus t squared minus 1/2, and the term inside becomes 2t, so you have t 1 plus t squared. So it is the same as this term right here, right? So square root of 1 plus t squared. So we know that this is equivalent to d 1 plus t squared 1/2. So you have square root 1 plus t squared plus c. Okay, so we know this is the same as minus 1 half y to the power minus 2 equal to square root 1 plus t square plus c. Okay, so let's write it right here. All right, so this is minus 1 over 2 y squared plus square root 1 plus t squared plus c. From the initial condition y0 equals minus 1, since y0 equals minus 1, then we have minus 1 over 2 minus 1 squared equals square root of 0, right? T equals 0, so 1 plus c, it is nothing but minus 1 half 1 plus c. C is minus 1 half minus 1, so minus 3 over 2. Okay, so we have minus 1 over 2 y squared plus 1 plus t squared. C is minus 3 over 2. So this is the solution, but we need to express it in the form of y, so just y appearing on this side, so we can first let multiply with minus 2. Okay, so we have 1 over y squared, so this minus 2 plus 3, right? Okay, so y squared is 1 over 3 minus 2 plus t squared. So y is 1 over square root of this term, 1 plus t squared. Wait, so this you have plus minus, right? So which one is it? The plus one or the minus one? To decide, we can check with the initial condition. So y0 equals minus 1. Okay, so we have minus 1 equals plus minus t0, right? So this is 0, square root of 1 is 1, so we have square root of 3 minus 2, so is plus minus 1 over 1, so plus minus 1, so minus 1, so we have minus sign. Therefore the solution is y equals minus 1 over square root 3 minus 2 square root 1 plus t square. Okay, so we have solved all of these problems. I hope you guys can follow the steps, and if you have any question, do not hesitate to email me or email Dr. Chow. And if you have any further questions, you can see me on my office hour on the next Monday. All right, thank you, and I'll see you later.